To determine the calculated load in amps for a school using the optional method, follow these steps. Firstly, convert the connected load from kilovolt amps, abbreviated kVA, to kilowatts, abbreviated kW. Given a connected load of 600 kVA, multiply this value by the conversion factor of 1 kilowatt per 1 kilovolt amp. This calculation yields 600 kVA times 1 kilowatt per 1 kilovolt amp, resulting in 600 kW. Secondly, determine the appropriate calculated load factor, often denoted as K. According to the National Electrical Code, NEC Table 220.87, for schools, the K factor is typically 0.5. This factor accounts for the non-continuous and diverse nature of electrical loads in educational facilities. Thirdly, calculate the calculated load in kilowatts. This is achieved by multiplying the connected load in kilowatts, obtained in the first step, by the calculated load factor determined in the second step. In this case, the calculation is 600 kW times 0.5, which equals 300 kW. This value represents the estimated actual power demand of the school. Fourthly, convert the calculated load from kilowatts to amps. To do this, divide the calculated load in kilowatts by the voltage of the electrical system. Assuming a typical voltage of 480 volts for a school, the calculation is 300 kW divided by 480 volts. It is important to ensure that the kilowatts are converted to watts before dividing by the voltage if you are doing it manually. 300 kW is equal to 300,000 watts. The formula to convert kilowatts to amps using single phase is amps equals kilowatts times 1000 divided by the volts. The formula to convert kilowatts to amps using three-phase is amps equals kilowatts times 1000 divided by the volts times 1.732. So for single phase, 300 kW at 480 volts is 625 amps. For three-phase, 300 kW at 480 volts is 360.84 amps. Therefore, based on a single-phase voltage of 480 volts, the calculated load in amps for the school is approximately 625 amps. If a three-phase 480 volt system is used, the calculated load is approximately 360.84 amps. When performing electrical load calculations, it is essential to adhere to the guidelines and requirements outlined in the National Electrical Code. The NEC provides comprehensive standards for electrical installations to ensure safety and compliance. The optional method, as referenced in NEC Table 220.87, offers a simplified approach to calculating electrical loads for specific occupancy types, such as schools. This method utilizes a calculated load factor to account for the diversity and non-continuous nature of electrical loads in these facilities. Understanding and applying the NEC guidelines is crucial for accurate and reliable electrical load calculations. In addition to the NEC, local electrical codes and regulations may also apply. It is important to consult with the local authorities or a qualified electrical inspector to ensure compliance with all applicable requirements. Local codes may have specific amendments or interpretations of the NEC that need to be considered. Accurate electrical load calculations are essential for the safe and efficient operation of electrical systems. Overestimating or underestimating the load can have significant consequences. Overestimation can lead to oversized equipment, increased costs, and reduced efficiency. Underestimation can result in overloaded circuits, equipment failure, and potential safety hazards. Therefore, it is crucial to perform electrical load calculations carefully and accurately. The calculated load represents the estimated maximum demand of the electrical system. This value is used to determine the appropriate size of electrical equipment, such as transformers, switchgear, and conductors. Selecting equipment with adequate capacity is essential to ensure reliable performance and prevent overheating or failure. In the example provided, a connected load of 600 kVA represents the total rating of all electrical equipment connected to the system. However, not all of this equipment will be operating simultaneously at its maximum rating. The calculated load factor of 0.5 accounts for this diversity, reducing the estimated maximum demand to 300 kW. This reduction allows for more efficient use of electrical equipment and reduces the overall cost of the installation. The voltage of the electrical system is another critical factor in determining the calculated load in amps. Higher voltages result in lower currents for the same amount of power. Therefore, using a higher voltage system can reduce the size of conductors and equipment required, resulting in cost savings. However, higher voltage systems also require more installation and safety precautions. The choice of voltage depends on various factors, including the size of the facility, the type of equipment used, and the local electrical codes. In the example, a typical voltage of 480 volts is assumed. However, other voltages may be used depending on the specific circumstances. It is important to consult with a qualified electrical engineer or contractor to determine the appropriate voltage for the installation. The optional method for calculating electrical loads is just one of several methods available in the NEC. Other methods, such as the standard method, may be more appropriate for certain types of occupancies or electrical systems. The standard method typically involves a more detailed analysis of the individual loads connected to the system. It may be more accurate for systems with a wide variety of load types or for systems where the diversity factor is not well known. The choice of method depends on the specific circumstances of the installation and the level of accuracy required. Electrical load calculations are an essential part of the design and installation of electrical systems. They ensure that the system is safe, efficient, and reliable. By following the guidelines and requirements outlined in the NEC and consulting with qualified professionals, it is possible to perform accurate electrical load calculations and create electrical systems that meet the needs of the facility. Remember to always prioritize safety when working with electrical systems. Electrical work should only be performed by qualified professionals who are trained and experienced in the safe handling of electricity. Always follow proper safety procedures and use appropriate personal protective equipment. When calculating electrical loads, it is also important to consider future expansion or changes to the electrical system. It is often prudent to add some additional capacity to the system to accommodate future needs. This can prevent the need for costly upgrades or modifications later on. The amount of additional capacity to add depends on the expected growth of the facility and the likelihood of changes to the electrical load. In addition to the calculated load, it is also important to consider the available fault current at the service entrance. Fault current is the amount of current that would flow in the event of a short circuit. Electrical equipment must be rated to withstand the available fault current to prevent damage or injury. The available fault current depends on the size and impedance of the utility transformer and the impedance of the service conductors. It is important to obtain this information from the utility company and to select electrical equipment with an appropriate short circuit current rating. Electrical load calculations should be documented and maintained for future reference. This documentation can be useful for troubleshooting problems, planning future upgrades, and complying with regulatory requirements. The documentation should include the assumptions made, the calculations performed, and the results obtained. It is also helpful to include a diagram of the electrical system showing the location of the loads and the size of the conductors. In summary, calculating the electrical load for a school using the optional method involves converting the connected load to kilowatts, determining the load factor from NEC Table 220.87, calculating the load in kilowatts, and converting the calculated load to amps using the system voltage. Always adhere to the NEC guidelines, local codes, and safety procedures when working with electrical systems. Consider future expansion and the available fault current when designing the electrical system. Document all calculations and maintain the documentation for future reference. This explanation provides a comprehensive overview of the process. It is important to consult with qualified professionals for specific applications. Understanding the fundamental principles of electrical load calculations is essential for anyone involved in the design, installation, or maintenance of electrical systems. By following the steps outlined and adhering to the relevant codes and standards, it is possible to ensure the safe and efficient operation of electrical systems in schools and other facilities. The National Electrical Code, or NEC, is a widely adopted standard for electrical installations in the United States. It provides comprehensive guidelines for the safe and proper installation of electrical wiring and equipment. The NEC is updated every 3 years to reflect changes in technology and industry best practices. It is important to stay up to date with the latest edition of the NEC to ensure compliance with current regulations. The NEC covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. It also includes specific requirements for different types of occupancies, such as schools, hospitals, and industrial facilities. The NEC is a valuable resource for electrical engineers, contractors, inspectors, and anyone else involved in the electrical industry. In addition to the NEC, there are also other standards and organizations that provide guidance on electrical safety and design. These include the Institute of Electrical and Electronics Engineers, or i.e. the National Fire Protection Association, or NFPA, and Underwriters Laboratories, or ALL. These organizations develop standards, conduct research, and provide certification services to ensure the safety and reliability of electrical products and systems. Electrical safety is a critical concern for everyone. Electricity can be dangerous if not handled properly. It is important to be aware of the hazards of electricity and to take precautions to prevent accidents. Some common electrical hazards include electric shock, electrocution, fires, and explosions. To prevent electrical accidents, it is important to follow safe work practices, use appropriate personal protective equipment, and maintain electrical equipment in good condition. It is also important to be aware of the signs of electrical hazards, such as frayed wires, cracked insulation, and sparking outlets. If you see any of these signs, report them immediately to a qualified electrician. Electrical codes and standards are designed to protect people and property from electrical hazards. By following these codes and standards, it is possible to reduce the risk of electrical accidents and ensure the safe operation of electrical systems. The information provided here is intended for educational purposes only and should not be considered a substitute for professional advice. Always consult with a qualified electrical engineer or contractor before making any decisions about electrical systems.